I am pleased to have Bill Batson, somebody that I met the first 2 weeks here on campus. We were attending a training together at the travel office. He was taking students to Nepal and he was learning the details of the requirements. And I was trying to get trained so that I can get the travel card as well, so I can go to some seminars as well. We started talking about places that we both like. Once I found out that he was an architect, we started talking about Zanzibar and other places like that, the architecture, that part of the world. And it started a friendship, and we have known each other since then, and we've visited each other a few times. So it's my pleasure today to introduce to you Bill Batson. He is part of the faculty here in the School of Architecture, and he runs the Curies program as well, the center director of that. And Bill, briefly about our speaker today. Bill received his BA in art and BS in architecture and his master's, of course, in architecture from Ohio State University. As director of the Curies Center, Bill seeks to provide opportunities for our students to learn and experience the architectural profession and develop and train PVAMU SOA, School of Architecture students to be visionary, these global leaders. And recently they had an interesting opportunity, which we featured in our review magazine, the research magazine, where UNESCO had provided them an opportunity to travel to Nepal and using some of the 3D laser scanning technology. They went over there to try and reconstruct and preserve this historic site, not from the perspective of building, but they'll tell us more about that, but trying to put together the plans and how that structure looks like. The structure is here today in its model form, and he'll talk more about that. So without any further delay, it is my pleasure to introduce to you Mr. Bill Batson. Thank you.
Good morning, and thank you for the opportunity, Awad. And as he stated, I'm the director of the Curies Center. It's community, urban, and rural enhancement services, whereby we seek to find projects for students, paid projects, where students can learn how to work and perform in the real world. Good, thank you. And our team today is Rodrigo Salvador and Carlos Esparza. There is another one, Armini Panichello and Ernesto Alviso and Nancy Guerrero. They're part of the team too. We had several others, Yesenia Davila and Giovanni de los Santos and Juan Carlos. They all participated in some of the projects, and this is our presentation today. You see that's the laser scanner, the 3D laser scanner that we use to scan and then transfer to 2D software and then to 3D software finally. So we set up there, that's Nepal, that's one of the directors of UNESCO, and one of the Nepali archaeologists on the left there, that's myself, that's Professor Song. He's the wizard when it comes to finding out exactly the kind of software. He's the one who found the best scanner. We have the latest and the best scanner around for the time being, because there's another one out that's half the price and it does almost what we can do, but we can still get some mileage out of it, and we're looking to do that. The other gentleman is our IT specialist, Pankaj Chetri. He is from Nepal, and it is his brainchild that we received the project. He was able to contact one of his old classmates who worked with UNESCO, and remember the 2015 devastating earthquake that damaged hundreds of buildings, some of them completely, and all of which they have no drawings for. So we were asked to perform a 3D laser scan and construct reconstructive archival drawings for the Pancha Deval, which you'll see. The 3D laser scan applications has architecture, as-built, historic preservation, mining, civil engineering, agriculture, archaeology, and criminal justice. You could probably see those on the nightly news more often than you would notice. There is a 3D laser scanner on the site so that they can have actual permanent records of the site scene. So we have many applications for the 3D laser scanner outside of archaeology. And these are our students. We scanned one of the projects, originated by the president. We were originally going to have a daycare center at the old school right at the entry of the campus, and now it's going to be a museum, historic museum. So we scanned it, and then our students performed the transfer to the software and reconstructed the entire building on CAD. And these are just some of the projects we've completed since we received the laser scanner. Our charge is to seek work, which we do, and so we've been seeking and achieving. So the existing building documentation, all the campus buildings, it's a mandate by Texas A&M to create a digital record of all the campus buildings. So our students went around and field measured with tape measures, measured the buildings, laser scanned several that were obscure and hard to access the roof. So we went around and we reconstructed all of the drawings, the digital drawings for the campus. The job was so successful, the administration continued the work for the next year, and so the students were employed for almost 2 years. The Early Learning Center, it's now the PV Museum, UNESCO Nepal, Freedman's Town. This is one of the first African-American towns in Texas, founded by former African slaves, and we scanned and laid that. The Baden Rock House, these are homes and architecture. You'll see those designed by African slaves and former African slaves. It's their vernacular. They need a smokehouse, they build a smokehouse. They need a barn, they make the barn. They make it without drawings, without any college knowledge, or without any architectural knowledge. They just do it by their own brain power. Shankleville, Texas, Cane River Creole National Park. There were 20 African slave cabins. There was only 7 left, and we laser scanned all of those and created reconstruction drawings for those. The Macedonia Primitive Baptist Church in Hempstead is one of the premier Carpenter Gothic churches left in America, and it's a jewel. It's been moved 3 times. It was in danger of being destroyed, and so we're trying to get funding, historical preservation funding. We've already scanned and measured that one. The Galveston, Texas, this is the fire station. 1903, you're going to see the drawings for that one. The Houston Historical Society, right outside of the library, there's another park, and there are these houses that were moved all over Texas, and we created the drawings. They were non-existent drawings. We created the drawings for that one. And the Baylor Female College, there were no buildings left. So what we did was we laser scanned what could be considered the footings or the foundation in situ, where there was only the foundation, the 90 by 100 foundation, limestone footings in the ground visible. So we laser scanned that. We had a footprint, and then the pastor had the parishioners bring in all the photos that they could from the past. So we had wedding pictures and old pictures, and one of the ladies brought in a picture from approximately 80 years ago where they were photographing all of the young ladies, and it had the full facade, front and side. So we were able to count bricks. Yeah, we count bricks and found elevations and reconstructed that one. You'll see that one. The Patricia Mosley residence, the Fourth Ward Community Center, and the Maloneson cabins. These are all of our projects. So we've been very busy with our students, and we've had volunteers and an excellent track record of completion and quality of work. This is our first project in Kathmandu, Nepal. We were invited by UNESCO to come and scan 5 historic Hindu temples. As you can see, the stucco has broken off. The Hindu Nepali architecture, called newer architecture, uses mud mortar. And the locals and the citizens of Nepal don't want to change to a limestone mortar, which is more stable. They want to stick with the tradition. So in the event of an earthquake, the mud mortar shifts and creates an absolute shear with the brick. So it shakes, it breaks off, and it's catastrophic. You can see the top, all of those 5 temples are severely damaged and in a state of almost imminent collapse if there's another earthquake. There were no drawings, and this is the project that we had. We scanned all 5 temples and created the working drawings. This is what happens. This is before and after. You can see the crumbling of the structure, and it's almost like matchsticks. And there's no drawings for this temple either. So the next one, this is Siddhi Saligram. This is the temple complex. As you can see, one of the temples up there, that's the king's father. And these are the senior citizens that live around the periphery of the 5 temples. They've turned the 5 temple complex into a senior citizen's home. So while we were scanning, they were out sunning their and washing their clothes. So we scanned within the compound. A very beautiful, very poignant, very mystical place in Nepal. And so some of them have severely damaged skin from diet and what have you. So they take their shoes off and they let their feet get the ultraviolet rays and kill the bacteria in their sores. And so we brought Vaseline, tissue, all those things. Our students collected 4 big plastic tins full of food and cosmetics for them. So we were working right next to them, scanning and moving around the entire 5 temple complex. And that is the beginning of the laser scanning. Sometimes if they're sleeping inside, we had to leave them alone and go to another one. So it was a very educational and rewarding experience to do this. And they were just the most peaceful people we have ever seen. And the trip to Nepal was very rewarding. We also did field measurements just to check. We use a scale. We use a tape measure, and we use that in conjunction with the laser scanner always. The typical documentation workflow is as follows. We have a site visit, Nepal, and we have site gathering information. We do a history. We have a history of the 5 temples, the year it was constructed, the style of architecture, and then we do site analysis and planning. We do a rough draft of where we're going to place all of the scanning laser points. You just can't scan a building. If you have 5 buildings, you have to have approximately 15 laser scans, and each one takes about 20 minutes. So it's a couple of hours of setting up, scanning, moving, setting up, scanning, moving. But once you get that, you don't have to come back again. You have a permanent, accurate record. And of course, you saw we did as-built measurements. And then post-scanning work, you transfer the 3D laser scan to software and then to CAD software. And then you present the drawings and the final outcome 3D lasers. And this is our final picture when we finished the Hindu temple. We're standing in front of the king's temple with the beautiful bell behind us. This is one of the aspects that we use. It's a point cloud import to AutoCAD. The laser scan takes 1 million points, records 1 million dots per inch. So that's really accurate to get the form of the building. Okay. And then you can see how the laser scan scanned a Roman catacomb artifact, and that's the 3D image, how accurate it can be. And of course, we can do laser scans of the topography, site master plans. We can do that. And as I stated before, we can also do reconstructions of buildings that don't exist. We can use pictures. This is the only thing left. As you can see, the foundation stones, 90 by 100, they went back there. And the only thing left were these 4 columns, and they kept them there. It's an icon now for their letterhead and things like that. This is one of the pictures that one of the parishioners brought in. It shows the height of the columns. It shows the number of windows. And we zoomed in on another one where the other side was on. We were able to count bricks. We were able to count the bricks on the chimney and the cupola. We lucked out. The cupola was mass produced. And so we looked through catalogs and we found the most accurate one and got the heights on there. And so from that, this was also another card, and that's another shot right there. So from that, we were able to reconstruct the entire facade, and they at one time want to propose a idea that they can reconstruct this college for women. It was one of the first colleges ever built for women in Texas. So it's a historic thing. As you can see, the 4 columns are still there, and we reconstructed it. And we also provide a era accuracy. We use scale figures, as you see, accurate scale figures, the women with the big flowery hats, and the horse-drawn buggies. There were no cars at the time. This is 1857. And of course, they had large 100-foot oak trees at the time. And then the next one, this is the Nichols Rice Cherry House in the Sam Houston State Park across from the library. There were no drawings. This house was moved from another location. It was going to be torn down. And so they moved it into the Sam Houston Park. Now, the Sam Houston Park is in a little valley right outside the library. Is anybody familiar? If you drive by, you'll never see it. It's hidden. It's the biggest kept secret in downtown. It's in a little valley, and the houses you won't be able to see from the street because they're below the street level. So you have to go through a gate, and there's these beautiful 6 or 7 beautifully historically preserved. And in the inside is preserved exactly how the owners left, including the lace on the tablecloth, the crystal, the chandelier, the tableware, the earthenware. It's really beautiful. So we laser scanned the Nichols Cherry, and our students created a plan and elevation drawings. The historic fire station number 3, this was in Texas, and 2 hurricanes hit it and destroyed the roof, and of course, the second one started to take the brick off. And so what they wanted to do was they wanted to preserve it. They do have a grant. The Galveston Historical Foundation has a grant, and they're going to reconstruct it. So we performed a laser scan of the entire fire station. One of the great things about the laser scan, not only is it accurate, but it also is a safety has a safety measure built in. We didn't have to go up on top of that roof to measure. Imagine us going on top of that roof and trying to measure. And then if you go inside, it's probably a 1/2 inch thick layer of pigeon guano. Everybody knows what pigeon guano is. So you're not supposed to breathe in pigeon or bat guano. It causes a lung disease. So being in there measuring is a health hazard. So we got a few masks on. We ran in there with the laser. We turned it on. We ran out. We waited 20 minutes. And we were able to scan the inside, the outside, and we worked with the engineering department, the Prairie View Engineering Department, and they created the reconstructing drawings of the structural roof. Architects were not licensed to do that. So that's what the roof looked like. It's caving in. No one can go in that roof. So the laser scan provided the opportunity to accurately measure without having anybody injured. So that's another benefit. These are the drawings that we created. Again, we do the era drawing scale figures. There's the fire engine drawn by the horses, and that's what it looked like before. They stuccoed all the brick, which was common across America in the 60s and 70s. They wanted to give the buildings a facelift, but now they want to go back to the original, and we were able to use an old photo from someone's photo album. So that's what it looks like today. It's very dilapidated, and that's what they want to go back to. Now, that stucco, when you peel it off, the brick is very clean and preserved very well underneath the stucco. So the next project is the Cane River Creole National Park, African slave cabins at Nacogdoches, Louisiana. There were originally 20, and this was one of the largest slave plantations in Louisiana and the largest cotton producer. We were asked to come and scan the remaining 8 cabins because no one has provided any drawings. So we got together with the directors of the Nacogdoches Historic Preservation Foundation. There's Sarah on the left and the park ranger, Judy. And they gave us a tour of the landscape of the plantation and opened the cabins for us to laser. And by the way, when you walk inside, there's 16 by 16 for one family, and it's a dirt floor. So, and it was very hot, and we dodged 2 hurricanes. So that's Professor Song and I doing our last laser scan. We're about to drop, and that's the inside of one of the slave cabins. So, It was very moving too. And what is happening is the moisture in Louisiana is deteriorating all of the brick very slowly, and it's disintegrating it back into the powder that it came from. So, and they're whitewashing it. Of course, the whitewash is chipping away. So that's one of the things that they are trying to remedy. And they have offers for engineers and conservators to come there in the summer as interns and work on trying to figure out ways to preserve the brick. And these are the reconstruction drawings of the slave cabins. And it's a beautiful site. It's on the bend of a river. You can see the site there. The soil is a foot deep with black, beautiful mud, Mississippi mud. The grass, you can see, is the most beautiful green. So it's kind of a melancholy being there in the most beautiful place and then having it being a former slave cabin. The Purple Hill Pea Festival, we were invited by the Hempstead, Addie and A.T. Odom to scan their vernacular slave architecture. So, and we were invited to come at the Purple Hill Pea Festival. They were here at a conference last year, if you remember. So, three of the buildings that we laser scanned and we were now still in the process of reconstructing was the barn. They built the barn, and if you can see, there's no other barn like this in America. They didn't have saws. They didn't have access to saws. These were former slaves. They needed a barn, they built a barn. So they would cut down tree logs, and if you look there, that's a log, and there's a log over there. And guess what the floors are made of? Logs, and logs roll. So I asked the patriarch, I said, how did they build this floor out of, who could make a floor out of round logs? And he showed me the joints that they made to keep them from rolling. So the necessity is the mother of invention. So, and it's a unique type of American architecture in this region. Also, and most people from the South know what a smokehouse is. They didn't have refrigerators, so what they did was they smoked the meat to cure it. And that's a smokehouse. It's a typical Southern smokehouse, but that was actually built also by the Africans who came from Louisiana. And let's see. All right, let's see. Is it going to the next slide? It's not going to the next slide. Or it's doing something. Okay, well, wait. Okay, I segue now to one of my excellent students, Rodrigo Salvador. He's going to talk about his participation in the Magnolia slave cabins. Cancel. Yes, sir. Okay, we'll hook it up with that. All right, thank you.
So when I joined had the opportunity to join the Cure Center in the fall of 2017, the project of the slave cabins had been awarded to us. We had applied for a grant, and I was invited to join the project. And this past March, we had the opportunity to go back and finalize the drawings to turn into the National Historic Preservation Center in Louisiana. And there was a group of students that traveled. We were there for 4 days, and we finalized some other scans that we had to do. And when I was first invited to join the Cure Center, we had the UNESCO trip coming up also. I had the opportunity to apply for the study abroad. we traveled to Nepal during the spring break uh, of 2017, and we were able to go and present 50% of the drawings that we had promised them we were going to be done the following August. And so they liked our project. They gave us the opportunity to go and look at more projects and see if we are open for any, which is we're seeking funding for the rest of the projects. They have projects in Venice that they have, or UNESCO has offered to us. Uh, we also went to the Tarragon Gallery. That's where most of the historic pieces are kept secure in Nepal. And they offer us to go and have a showcase, a gallery, whenever we have completed reconstruction drawings, as is right now, and as built with 3D models. And we're also planning on going back in the near future. They have offered us for next June or next December, where they will have their annual gallery showcase. So that's what it would be. That's as built. That's what they looked when they were originally built. And Professor Batson already showed us what it was, the status of it now is. That's the group of students that traveled to Nepal. It was a great opportunity for everybody. We were assigned a building, do a research. One thing our proposition was, let's take, they use mud to build the buildings. And what if we mix at least 5% of limestone in the mud? We know you don't want to use limestone for the reconstruction, but if you mix at least 5 to 15%, you preserve the history of what they have used over time, but you still give it a more stable base to the reconstruction in case of, in Nepal, it's not when it's in case of another earthquake. It's a matter of when it's going to happen. There's earthquakes. And just 3 days ago, there was one recorded at 5.3. So it's just a matter of when it's going to come again. So if you mix at least 5% of limestone to the mud, you give it that 550. It makes the building stronger. And they're thinking on that, and hopefully they will take it for their own good. And Carlos, he's going to talk about the 3D model and.
All right. Hello. So for the future works, we decided to continue the 2D drawings and develop them more into a 3D aspect. What I worked on for the Pancha Dewa temples was what you see in front of you. The temple is being worked on. It's at, I would say, 50% of the work done. To make that, it's been a progress of like just about 3 to 4 months. Um, the 2D drawings were super precise, and we decided to take them into 3D. I provided the 3D skills in AutoCAD for us to continue that. Um, we decided to divide the drawings into 4 pieces: the splint, the bottom part, the middle part, and the top part. The spire being the hardest one. Uh, it's been a project that has enabled us to use the fabrication center. The fabrication center, of course, providing the 3D printing machines, um, has enabled us to print such a big project. This for 3D printing is a relatively large project, and therefore we decided to take advantage of the 3D printers. With this, it was just the 2D drawings and changing them into the 3D. A lot of making sure it was a flat drawing, um, making 3D shapes out of what Professor Batson's had provided, and evolving a lot of uh, subtracting, a lot of additions, and making sure that the smallest details were part of the temple. The next part of the project here would be making the bottom part in this plinth, which would add another 10 to 12 inches in the final product. And therefore, uh, the, the total height of the building would end up being at about 22, 20 to 24 to 26 inches. Hopefully, we can finish that within a month. That's definitely the goal, at least for me, is to finish this as soon as possible. I think, yeah, I think that'll be all. Hopefully, hopefully, hopefully we finish this and provide the final model uh, for y'all and within the next month. With that being said, I think that concludes the presentation. Thank you, and I think now we're open to any questions from the audience.
Okay, open to questions, comments, feedback. I have one question. The application of this in ag, because we have a lot of people here who come from agriculture, and I noticed that you listed one of the areas that you can apply this technology or the different other fields. One of them is agriculture. Do you know of any examples where it probably could be used in ag, or in what circumstances, or what setup, you know? This, we'll give you a mic, yeah, so.
He's going to pass it around.
Oh,
It's actually two pieces.
model? Yeah.
The laser scan can be used for topography, the different elevations, and to show different drainage patterns, how to level off a field so you can plant and you can minimize the erosion. So, but we haven't done any on agriculture or criminal yet.
Have you used LiDAR technology in 3D scanning using drones or, you know?
If you look right here, you see the little dog at the top? The further up you get, the more you need the drone. Laser does 300 feet up in the air, and it can only scan what it sees, but it scans it accurately. But the top of the gargoyle is not scanned. So we were missing that layer. So we have enough pictures, but we would like to use the drone, but we're not allowed to use it.
But you can use it in any other location.
Actually, the drone is becoming more sophisticated, and it may replace our 3D laser.
Yeah.
So and we don't want that to happen because so we want to get some use out of it before technology.
Sure, you can, of course.
Thank you.
Yeah, it's there's a couple of additional pieces of information that are happening right now that Professor Batson is alluding to. You actually can couple the 3D laser scanner with ground penetrating radar that actually can let you go down to about 10 to 15 feet below the surface. So you can not only do a 3D scan of an object above the ground, but you can also do a ground penetrating model of what is below the ground that you can use it to track and trace and do all kinds of stuff. The other thing that is happening right now in the industry is with the addition of the drones, they actually are laser scanner mounted drones that actually will do the scanning from above. And there's also robots that actually go inside the building that you don't have to send somebody. So for example, if you need to scan between the ceiling and the slab or areas that people can go in, they have programmable robots that actually go in and they'll give you the image back. And one of the things that is happening right now is that they're using the 3D models that are created and couples with the robots, and they're being basically superimposed on existing buildings, and they're using for forensic. Every time there's an earthquake, they can see why and where the reasons of the failures. So the technology is sort of kind of enter a completely new way of looking how we did things or how we do things.
Okay. I have a question. I'm glad to see that you guys are doing this kind of thing. So I heard you say that you guys was looking for work to do.
Yeah.
Okay. He is. Oh, okay. So anyway, we are looking at doing some upgrades maybe to our greenhouse. And so, would you guys be willing to talk with us to kind of do a view of it and maybe do a design, a layout of that
Sure.
area?
Sure.
Okay, you have a card?
I do.
All right.
All right, you have a question?
Yes, Bill and team, very nice presentation, very nice project in Nepal. I was wondering if this is a way for you to extend the relationship with UNESCO. So they've been known to do some really nice reconstructions, like they did the Timbuktu reconstruction in Mali, which is a really big project over like 2 or 3 years
Well,
of the
they have,
of the mausoleums there. So I was wondering if you could use this as evidence that you're able to execute on a UNESCO project and go for a bigger one and have it be a an annual thing for you guys.
they have offered us future projects. It's
In Mali?
they have offered, well, not necessarily Mali. They have
Okay.
offered us
Yeah.
projects to go to Venice, to go to other. They have offered us projects all over the world, and it's just we have to find the funding to go and see those projects. That's the hardest part on it.
So, okay, all right.
I highly want to put in a pitch for Venice, since, as you all know, the city is sinking and is basically going to disappear. And I've been once, so I'd like to go back and not get all my clothes wet. So if you guys could do something about that, that'd be good.
One irony when we traveled to Nepal.
Give him the mic so he can, yeah.
The first time I traveled, our president removed our participation in UNESCO. Remember?
Oh, I'm sorry, we didn't get that. You said what now?
Our president removed United States funding from UNESCO.
Ah.
Remember,
okay.
there was a report. UNESCO approved a Palestinian project, and after that, the American government decided not to fund UNESCO because of the political situation. So we were caught between a hard place. When we got there, we say, "Well, you Americans don't support UNESCO. What are you doing here?" So we've got to sort of tiptoe around that too. So that's kind of a stickler for our country, and we didn't even know about it until they told us. We didn't. It was a decision made. We didn't know that for as long as I've been alive, we've been part of UNESCO. So, but we would love to do. And we wrote to the president of France, and there at Notre Dame there is a statue of Charlemagne adjacent. It's the most, I tell you all, it's the most spectacular statue I've ever seen in the world. He's on the most beautiful carved horse in bronze with a scepter. He's about 3 times life size. And Charlemagne was German, and the Germans took over Gaul and made it to France, the land of the Franks. They're German. So these two Germanic barbarians are holding this horse down, and Charlemagne's at the top. And it's a beautiful statue pushed to the side of Notre Dame, and Napoleon put a highway in there and tore down all the structure. So it could only be viewed from 3 sides. So our proposal was we wanted to come to France and laser scan the entire site, including the statue of Charlemagne, and remove it to another square. One of our students found a empty square in France where it would be perfect. It's a drive around. And a month later, what happened to the Notre Dame? We would have had the most up-to-date scans of that building right before the fire. So we still want to do that project. So
Other questions? Anybody? Okay, another round of applause for our group from School of Architecture. Thank you so much for joining us. I don't know, I think this concludes the seminar series for this semester, as far as I know. We continue next semester. Thank you all for coming, and have a wonderful rest of the day.